Valve pocket and seat work represent a critical phase in cylinder head porting, where precision and attention to detail can make the difference between a subtly improved engine and one that achieves truly optimized airflow. This step is all about enhancing the critical area immediately surrounding the valve, commonly called the throat or bowl, while ensuring that the transition from the port to the valve seat is as smooth and efficient as possible. This is a delicate balance. The goal is to improve the path air takes into and out of the combustion chamber without removing so much material that the structural integrity of the head is compromised, or that airflow characteristics are actually degraded. The process begins with careful preparation and a clear understanding of the objectives. The valve pocket, or bowl, is the area just beneath the valve seat where the port opens up into the combustion chamber. In stock cylinder heads, this region is often left with abrupt edges, casting irregularities, or less than optimal shapes that can create turbulence, slow down airflow, and reduce engine performance. The aim is to open up this area, smooth sharp transitions, and create a more gradual, streamlined path for the air-fuel mixture to flow past the valve and into the chamber, or for exhaust gases to escape. Using a ball or flame-shaped burr, a rotary cutting tool designed for precision material removal, the porter carefully enlarges the throat area. The choice of burr is important. A ball-shaped burr offers control and is less likely to gouge or create uneven surfaces, while a flame-shaped burr can help reach tight corners and blend curves. The tool is guided steadily, with frequent pauses to check progress. The key measurement here is the throat diameter in relation to the valve diameter. For most high-performance applications, experts recommend that the throat should be approximately 85 to 90% of the valve's diameter. This ratio strikes a balance between maximizing flow and maintaining the velocity of the air charge, which is crucial for efficient cylinder filling and scavenging. As the burr removes material, the port shape begins to change. The porter focuses on the transition zone, where the port curves into the seat, smoothing out any abrupt changes in direction. Any sharp edges, ridges, or casting imperfections are carefully blended away. The process is methodical. Moving too quickly or aggressively can result in removing too much material, possibly compromising the seat or creating a thin spot in the casting. Once the general shape of the pocket is established, attention turns to blending the valve seat itself. The valve seat is where the valve physically contacts the cylinder head to seal the combustion chamber. It's often cut into the head at a specific angle, typically 45 degrees for the seating surface, with additional angles above and below to improve flow. Using a smaller ball burr, the porter gently works to blend the edge of the valve seat into the newly shaped bowl. The aim is to eliminate any step or ridge that could disrupt airflow as it passes over the seat and into the chamber. This blending process requires a delicate touch, as the seating surface itself must remain undisturbed to ensure a perfect seal. In performance applications, a multi-angle valve job is common. Instead of a single angle where the valve meets the seat, multiple angles are cut into the seat using a specialized valve seat cutter. A typical 3-angle valve job, for instance, might have a 30-degree top cut, a 45-degree seat, and a 60-degree bottom cut. More advanced heads might use 5 or more angles. Each additional angle helps to refine the transition from port to seat, encouraging air to flow more smoothly and efficiently around the valve. After the angles are cut, the blending process with the small burr becomes even more important, ensuring that each transition is seamless. Throughout this process, it is absolutely essential to avoid overcutting. Removing too much material in the throat or near the valve seat can weaken the cylinder head casting, lead to cracking, or thin out the seat area to the point where it cannot withstand the forces of combustion. It can also disrupt the delicate balance of air velocity and flow, resulting in an engine that actually loses power, especially at lower RPMs. To avoid this, measurements are taken frequently using precision calipers. The porter checks the throat diameter, the seat width, and the remaining material thickness at every stage, making incremental adjustments rather than sweeping changes. It's also important to maintain consistency across all cylinders. Each port and valve pocket should be matched as closely as possible to ensure that every cylinder receives the same amount of air and fuel. Variations can lead to uneven power delivery, misfires, or even engine damage. Many experienced porters use templates, scribe lines, and other reference marks to ensure their work is repeatable from one cylinder to the next. Once the valve pocket and seat work are complete, the surfaces are carefully cleaned to remove any metal shavings or abrasive residue. The valve seats may be lightly lapped to ensure a perfect seal. The result of this painstaking process is a bowl and seat region that allows air and exhaust gases to flow smoothly and efficiently, maximizing the performance gains from the porting process. Ultimately, valve pocket and seat work is a blend of science and art. It requires a clear understanding of fluid dynamics, a steady hand, and a commitment to precision. The payoff is substantial: improved airflow, better cylinder filling and scavenging, and an engine that can breathe more freely, making more power across the RPM range. By carefully opening the valve pocket, blending the seat, and avoiding the pitfalls of overcutting, the porter lays the foundation for a high-performance cylinder head that will help the engine reach its full potential.